Welcome back. This is a teaching video on section 6.1, Force Causes Acceleration. This is also section 5.1 in your textbook. This whole chapter has one big idea that is kind of the central thing everything else is built around, and that's that an object accelerates when a net force acts upon it. Remember, net is whatever's left over after everything fights. Okay, so if you are arm wrestling with someone and you're winning, it doesn't mean that there's no force coming from the other player. It just means that you have more force than they do. You have a net force that's making his hand go towards the table or whatever. Or maybe you're losing, don't know. But a net force acting on any object is going to cause that object not just to move, but to accelerate. So a mass is accelerated by a force. That's the big idea. So just a bit of review. If you review the definition of acceleration, acceleration was a change in time, a change in velocity over a change in time. So whatever time elapsed, if you got faster or got slower, if your velocity changed during that time interval, you've accelerated. So even if you've gotten slower, it's still a negative acceleration. It's still considered an acceleration. If you've gotten faster, obviously it's an acceleration. So this section, very, very short, is that an unbalanced force or a net force acting on an object always causes that object to accelerate in the direction that the force was exerted. So if you have more force acting this way and a tiny little bit of force acting this way, then whatever is left over after it's subtracted is going to make an object accelerate in that direction. The object accelerates in the direction of the net force. So, example, when a hockey puck's at rest, the net force on it is just the support force of the ice plus the gravity of the puck, and so it's balanced and it doesn't move. Remember, you can, if it's not moving, it's in equilibrium. If it's moving at a constant speed, it's at equilibrium. So if you roll a soup can across the table and it's the same distance every second, well, it's rolling at a constant speed. It's not getting faster and it's not getting slower. It's a constant speed. But if it's accelerating at all, so if you roll it down a ramp and it's getting faster and faster and faster, the only way that acceleration could happen, or if it's getting slower if you roll it up a ramp, is because there's a force acting upon it, in this case gravity. So we've got a little guy here. This is a math term. It's directly proportional to. So you can see that acceleration is directly proportional to, you can also use the fish, as proportional to the force. Okay, so if you add a mass to this, Newton will come up with this in one of his laws. You'll say that force equals mass times acceleration. You'll see that acceleration and force are on opposite sides of the equal sign. So what that means, as force increases, your acceleration increases. So if you have an object and you have a net force on that object, now you have more force on that same object, it will go accelerate faster or accelerate at a higher acceleration. So if you throw, let's say you throw with all your strength and you throw a baseball or you throw a bowling ball, you're not going to make it accelerate as fast, okay? There's no acceleration. The force, that's a bad example because that's a projectile. Let's do an engine. I have a little pipsqueak car and you have a big supercar. Your supercar has more torque, more force, and you can make your car accelerate more than my pitiful car can. That's the idea. You have to have some force that's acting upon it. So kick a football and it neither remains at rest, okay, so it's not in equilibrium anymore, it's moving, and it's not moving in a straight line, it's not moving at a constant speed, so it is the acceleration of that football. It was going from slow to fast very, very quickly, and it accelerated. You accelerated that ball right at the very beginning. Now it's not accelerating here, but it was certainly accelerating here. When as the foot was still on the ball, you were accelerating the ball. As soon as the ball leaves your foot, it's no longer accelerating because you don't have a force on it. But as long as your foot was on the ball and a force acting on that ball, you were accelerating it. So what causes an object to accelerate? Think about it.